Hello and welcome to another video. This time this was a question suggested. This was a question suggested by Emma. Hello, Emma. This is a horrible question. I think it came up last year on the right at the end of the Core Pure paper. I think the rest of the paper was nice, but I remember Lucinda, who sat this paper, who's an old student of mine, actually saying like I could do everything, but I couldn't get I think she did actually get to here, but I think she just kind of collapsed towards the end. And I'm not surprised either. In exam conditions, this is stressful. Now I have actually just done a video on exactly this, but I just got so messy in the end with the algebra. I had some second thoughts at the end. Look at that last expression I had. I just couldn't be bothered to tidy it up. I'd kind of lost the will to tidy after doing that. But I want to try and give us another strategy so that we don't end up with just too much writing down of maths. So I'm going to suggest doing this. Now, naturally, you can see that this is just going to be applications of product rule and chain rule. Yeah, and cosh and shine are really easy to differentiate, but I think it will help us much more. I'm going to try this time. If we just say at the start of the question, let C equal cosh 2x, yeah, and S equals shine 2x. I think it's going to save us a lot of aggravation. There's other things I'm going to do as well to try and make this easier. Okay, so in which case, if y equals c to the power of n, that's really what we've got, then dy by dx is going to be, well, remember that when you're differentiating c, you're differentiating cosh 2x, and that's going to differentiate to 2 shine 2x, which in my situation is just 2s. But then you're going to have to differentiate stuff to the power of n, and that's going to differentiate to n times by the stuff to the n minus 1. Now I just think, do you see what I mean? That if we use this notation, then it's just going to save our sanity really. We might just escape this question alive. Okay, so I've written that down, and then I've got to differentiate again. Now what would be kind of useful actually, what I did, and I did this in the previous video which I made. Zoomed out too far, sorry, I'm getting really confused where I am. I lost a bit on the screen where I am. Where am I? Okay, yeah. What might be nice to do is to actually introduce y in this so that you can just make the differentiation a bit easier. I think it becomes a bit easier if you can just use implicit differentiation, because y is cosh 2x to the n, yeah? And so rather than writing, here I've got cosh 2x to the n minus 1. Now, cosh 2x to the n divided by cosh 2x will give us cosh 2x to the n minus 1. So I could write this as y over cosh 2x, or even better, I could just times by cosh 2x2x both sides. But I'm writing down c for cosh 2x in an effort to save my sanity. And then I'm going to have 2nsc to the n, yeah? Now the reason I've done that is because I can now write that as c dy by dx equals 2ns y. Yeah? I prefer it like this, I really do. I prefer this notation. Okay, so what have I got here then? I'm going to differentiate again. Now I'm going to need a product rule on this, because remember c isn't a constant here, it's a variable. I'm going to need product rule over here. So I'll differentiate the c, but cosh 2x differentiates to 2 shine 2x, so that'll be 2s. Times it by the other side undifferentiated. Then I'll differentiate this and times it by that undifferentiated, so that's going to give me c d2y by dx squared, and that's going to equal, now personally I let the 2n just sit outside because it's just a constant. Differentiate s, you're going to get 2c, times it by the other side undifferentiated, plus differentiate y, you're going to get dy by dx, and then you're going to times it by the other side undifferentiated. Yeah. Okay, now if we just collect this together, let's collect the dy by dx's and then gradually try and turn it into the answer. Okay, let's do that. So I've got c d2y by dx squared equals, well, I think you can see I'm going to get 4ncy there. But here I'm going to have 2ns dy by dx minus 2s dy by dx. Well, I can take out the 2s dy by dx there and just make it n minus 1. Yeah. Now, at this point, we want to get to, what do we want to get to? We want to get to this, yeah? So I better start, this hasn't got any y's or dy by dx's in it, so I better start replacing my y's and dy by dx's with what they are, yeah? Remember, y is c to the n, yeah? So I'm going to have c d2y by dx squared equals 4n. Right, okay, c times c to the n is c to the n plus 1, yeah? And then over here, I'm going to have, now I want to get rid of the dy by dx. Well, dy by dx is the same as 2ns c to the n minus 1. So I'm going to have if I replace, let's just make it clear what I'm doing here, this with 2ns c to the n minus 1, what am I going to have? Well, I'm going to have to times all of that by 2s, so that's going to give me 4s squared n c to the n minus 1, I don't like the order in which I'm not ordering this, times by n minus 1, yeah? Okay, now you'll notice there's no shines in their answer, so I'm going to change that s squared to, using the standard cosh squared 2x minus shine squared 2x equals 1, 2x, and so shine squared 2x is, of course, which is what this is, equal to cosh squared 2x minus 1. Yeah, so I'm going to replace that with what it is. So I've got c d2y by dx squared equals 4n c n plus 1 plus, okay, so this is going to be 4 times c squared minus 1 and then I'm timesing it by c to the n minus 1, and I'm also timesing it by n times n minus 1. Okay, bit of tidying up. Let's divide through by c now. We're going to get 4nc to the n plus, now here, if you look carefully here, the c squared times by c to the n minus 1 is going to be, oh, sorry, I'm dividing through by c though, aren't I? So that's going to become c to the n minus 2. I won't do this too quickly. Let's just do one thing at a time. Ooh. N times n minus 1. We're almost at the answer. We're going to have 4nc to the n. Now if we multiply this out, we're going to have plus 4c to the n. I'm just putting that in the brackets at the moment, minus 4c to the n minus 2. Yeah, but I've got to times all of this by n and n minus 1. Yeah. Okay, right, so let's do that. What I'm going to end up with here is basically the answer, because if you look, I'm going to have 4nc to the n plus, okay, let's times it through by n first. Now I've just got to times it through by n minus 1, and this is where I'm going to get the 4n squared from, and why I'm going to lose a 4n when I times it through by n minus 1, because I'm going to end up with 4nc to the n plus, okay, let's times them both by n, 4n squared c to the n minus 4n squared c to the n minus 2, but then I'm minusing 4n c to the n, and I'm minusing 4nc to the n, and I'm adding, sorry, 4nc to the n minus 2. Okay, cool. Let's just have a look at this. So in the end, what cancels? Well, the 4nc to the n goes with a 4nc to the n, and you're left with, I probably should have simplified it a little bit nicer than this, but it did feel like I was going a bit around the houses there. What am I trying to end up with here? Let's remind myself of the result by pulling it down here. Okay, right, it's just over there. Let's have a look now. Okay, it is a fiddly one. Okay, so I should have 4n squared cosh to the n. Well, basically 4n squared cn. I've got that, yeah? That's good. I'll write it now in their form. Because remember, my c is just cosh to the 2x. And then I've got, what have I got here? Minus 4n squared. And basically, if I factorise that back out and take out the 4, yeah, all I've got to do is just factorise this. Now, if there's a plus, no, it's a minus, so let's take out minus 4n, well, yeah, let's take out minus 4n but let's also take out the c to the n minus 2, and then I'm just going to have to times this by n to get the minus 4n squared, and then minus 1 to get that, and that is exactly their answer, because there's cost n minus 2x. There we go. So it's worked out really nice. That worked out nice. I'm quite happy with this way of doing it. I feel like I've saved perhaps some students some aggravation there. Oh, and I'm just going to order it the same way they've ordered it as well. So yeah, that's always a possibility. I've shown you this before with some questions ages ago in the single maths course, where I've said, you know, sometimes you're better off saying let c equal sine x and s equal cos x. It can just reduce the algebra a little bit. So okay, that's that bit. Okay, so determine an expression for d4y by dx to the 4. Okay, I'll have a go at that. Well, I'm going to go back to, because I don't like this format, I really don't. I preferred the format I had it in right up here, yeah? Sure, you know, maybe, yeah, I would have kept the y and the dy by dx in, yeah? So, okay, I might collect it together, and I think I've collected it together. I'm going to use, all the way back up here, I'm going to use this bit, yeah? To find my d3y by dx cubed, and etc, etc. Okay, so, might even just screenshot my work there. Okay, so let's just try and write that down, or just do it over here and start. I'm just going so c d2y, I'll tell you what, let's call it cy dash. Cy dash dash equals 4ncy plus 2 sy dash n minus 1. So this is just going to be lots of product rule again, isn't it? Yeah. We're just going to basically differentiate this. You're going to get 2s, because remember cos 2x differentiates to 2 sine 2x. Times it by this undifferentiated, but then differentiate this and times it by that undifferentiated, and you get that. And that's going to equal, okay, once again product rule, put 4n there and just leave it alone. That's going to be 2sy plus c plus cy dash. Yeah. See how much quicker you can actually do this question when you do that. You just don't end up writing down so much stuff. Look for brevity here. Okay, leave 2n minus 1 outside, and then when you do product rule on these two bits, which are the variables, you're going to have 2c y dash plus s y double dash. Yeah, and there you go. There's your expression for the third derivative. I'm going to star that because I'm definitely going to use that in a second. And now I'm going to try and find an expression for d4y by dx to the 4. Now, they just said expression, so I presume I can have any old expression as long as it's correct. Let's make the marker work for it, as they've given us such a harsh question. Okay, so I'm going to differentiate this product rule again. I'm going to leave the 2 outside. I'm going to get 2c y double dash plus s y triple dash. And then for this bit, I'm going to have 2s y triple dash plus c y 4 dashes. That's your d4y, or IV, I think they normally do. It's, you know, it's basically Roman numerals. Okay, equals 4n, leave that alone. And then we're going to have, slightly annoying, we have to do so many repeated product rules here. I suppose maybe I should have tidied it up, but that's what you get. Okay, 2s is going to go to 4cy, and then you're going to have plus 2s y dash plus 2s y dash plus and then c y double dash, and then lastly 2m minus 1. Oh wow, what a long expression. No wonder I wanted to shorten it. Okay, here I'm going to have 4s y dash plus 2c y double dash. Can I just squeeze this in? Give me more space, please. Give me more space. Plus, so we'll have 2c y double dash plus s y triple dash. Okay, make sure that this is legible and zoom out. That's the longest expression I've ever written down in maths, I think. Okay, so here, there we go. So we want the fourth derivative, and that's only given by this term here. Everything else is free derivative, second derivative or third derivative or first derivative, just y on its own. And so I just need to move that over there. It might be wise to actually simplify some things at this stage though. What can I simplify? Let's have a look. There we go. I've got a triple dash here, and I've got a 2s triple dash, 2s triple dash. So that's going to be 4sy triple dash. That's that one and that one dealt with. And then I'm going to have 4cy double dash. And then I've got my cy fourth derivative. And then what can I simplify over here? I'm sure I'll be able to simplify this further. Just a painful question, I'm afraid. What have we got here? We've got, okay, 4cy, well, we can't put that with anything, but I can put those together as 4n, 4cy plus 4sy dash plus cy double dash. And then here with 2 bracket n minus 1, I'm going to have, put those two together, I'm going to have 4sy dash plus 4cy double dash plus sy triple dash. Cool. Okay, so I'm almost there. At the end, I can now finally put all these together. I can probably marry those up with some of the second and third derivatives over here, but I might not bother because they just said determine an expression, and in that kind of like environment, I'm going to be like, well, here's your expression, now leave me alone. Okay, so I've got y. Yeah, I really wish I could. Let me just move this out of the way. That's better. Okay, so then I can actually do work with space. Okay, so what have I got here? I'm going to at the end say cy. Yeah, well, let's actually write it as cos 2x. Yeah, or just d4y by dx to the 4. That's going to be equal to 4n 4cy plus 4sy dash plus cy double dash plus 2 bracket n minus 1 4sy dash plus 4cy double dash plus sy triple dash, and then lastly minus 4cy double dash plus 4 minus 4sy triple dash. Oh, but I've got to divide it all by cos x, so let's times it all by 1 over c. Yeah, and let's just hope they give you a mark for that one. You're kind of losing the will to live at the end of that. I would like to say, when I did it before with earlier, it also got awkward, but it wasn't too bad actually in the end. I will happily maybe do the video the other way. Mind you, look at my final answer. It's just ugly, yeah. But the thing is, I don't mind the first, second, and third derivatives being there because it's much easier at this stage, yeah. When you get down to the last bit, where's my working out here? When you get down to the last bit, when you've got to do your Maclaurin's expansion, to do that, you just need the values of y at x equals 0, y dash at x equals 0, y double dash at x equals 0, so on and so forth. We can easily do this, yeah? Because let's just work it out. Okay, so x equals 0. We're going to have y equals, okay, cos of 0 is 1, yeah? But we're going to have y dash equals, right, okay, let's have a look at dy by dx. Well, that's 2n shine 2x. Well, that just nukes it and makes it all 0 because shine of 0 is 0. So that takes a value of 0. What about y double dash? Well, let's have a look. I think this will take a value. Well, y double dash, we might as well use the one they gave us actually. It's here. Cos is 1, yeah? And so this is just going to be 4n squared minus 4n n minus 1, yeah? But that simplifies, doesn't it, to 4n squared minus 4n squared plus 4n, so just 4n, yeah? Now y triple dash, what's that going to equal? Well, let's have a look at y triple dash. I do have a y triple dash. Look, I started up here very sensibly. Okay, we're just plugging in. Shine's a 0, yeah? So any s's you see there, just ignore, yeah? Ignore, yeah? And y dashes and y, what was a dash again? Y dash is 0, so cross out any term with a y dash. Okay, that's that one. And that's that one. Okay, so y treble dash, this is going to be 1, it's going to equal 0 on this side, and so y treble dash is 0. There we go. and then y fourth dash. Well, let's have a look if my crazy zany way of doing it has done me a favour or not. Okay, so remember, let's just recall, y dashes and y3 dashes are zeros, but y double dash is 4m, yeah? So, and s is 0, so cross out your s's. This is going to be, now I said y, now what was it? What is y? Y is 1, yeah? So this is going to give you, and c is 1. So you're going to end up with 4n times by 4 plus, now that's cy double dash, and that's 4n, yeah? So that's going to be 4 plus 4n. And then we've got plus 2n minus 1 times by, okay, y double dash was 4n, yeah? And so we're going to have 16n here. And then minus 4 times 4m, so that's 16n. And then we're timesing it all by 1 over 1, but that's just 1. Okay, so this simplifies too. Let's see what we get. 16n plus 16n squared plus we're going to have 2n times by 16n, which is 32n squared, yeah? And then we're going to have minus 2 times by 16n, well that's minus 32n, and then we've got minus 16n, yeah? So what have we got here? That 16n is going to cancel with that 16n. This is going to become 48n squared minus 32n, yeah? And there we go, we've got the fourth derivative. So now we should be able to actually just work this through, if you see what I mean. That's what we should be able to do. So let's work it through with the Maclaurin's expansion. The Maclaurin's expansion says, shall I quickly put over the formula from the formula book for Maclaurin's? It's not very complicated, or I could write it down, I suppose. Let's just put out the formula book. 1 second on my other screen, I'm just going to look up the formula booklet. Yeah, sort of in reflecting on the way I've done it here, I mean, it's just an awkward question. You're going to have very heavy algebra whichever way you do it. You really are. There's not really any massive shortcuts, I think, even with my suggested method. But and I did do it the other way as well, like I say, but I looked at that video and thought, surely I can do him a favour here. Okay, so what do we have for this? We had 48n squared minus 32n. And so we want just the first three non-zero terms, so we're going to have y at x equals 0, well that's 1. And then we're going to have x times y dash, but that's going to be 0. And then we're going to have x squared over 2, so multiplied by 4n, that's that, and so that's just going to be 2x squared n, and that should be okay. And then we're going to have plus a 0, and then on the fourth term we're going to have x to the 4 over 4 factorial times by now let's do this wisely. If we can take out a factor of, what can we take out a factor of here? A factor of 8, yeah, and that's got a factor of 8 on the bottom, and this comes to 6n squared minus 4n then. And so what have we got? At the end we've got 1 plus 2nx squared plus, you're going to be left with a 3 there on the bottom, which I don't think you can get rid of, but the 4 and the 2 will cancel with the 8, so let's make that a 3. And so you're going to have 6n squared minus 4n over 3 x to the 4, I think. Yeah, cool. Okay, hope that made sense. It's an ugly question. I hope as well that in the mark scheme they'll give me full credit for what I'm doing here. Like, make the examiner work for it on that kind of question. It's like, well, you've made me work, so I'm going to make you work now. That should be equivalent to the answer. I bet it doesn't look like that in the mark scheme. I bet it doesn't. But provided I've got this last bit right, it must be correct. So, you know, they can chew on that. Okay. Yeah, hope you enjoyed that, and bye-bye.